Hello, this is section 5.2 IBGP. Okay, configure BGP on devices in the network according to the table below. In AS 65012, we have IBGP neighbor between R1 and switch 2. Okay, let's see here. We have IBGP between R1 and switch 2 and R2 between switch 2. This is here. This is IBGP neighbors. This is IBGP. We have IBGP here. And in AS 65056 we have IBGP neighbor between R5 and 7 and R6 7. This is IBGP here. IBGP. We have UBGP and IBGP here between devices. Okay. Ensure that the IBGP session in AS65012 can withstand a single link failure. Okay, it is in IBGP session where this is. We have to configure them so that it can be withstand by link step failures. If link fail, if physical links fails, IBGP session should be set up. Okay, we can do this by using loopback interfaces. We can make them neighbor by loopback interfaces instead of physical interfaces. We can configure loopback and we can set neighbor as neighbor address as loopback address of them instead of physical address. And if we configure loopback address as neighbor, then we have to use update source command either. Update source to tell the neighbor that I am using loopback interface as source for neighborships. Okay. Same here. I have to use loopback loopback interface as their neighbors. Then use update source on devices. Okay. R1, R2, R5, and 6 must be able to receive routes from other ASs if the corresponding IBGP neighbor goes down. Okay. 1, 2, 5, and 6. If the links first, if the IBGP links first, for example, if link between R1 and R3 first, they have to receive routes from they have to route from R4 if this link between R1 and R3 first. R1 should receive routes from R4. Okay, for this to happen, I have to have full mesh between IBGPs in between these devices for this to happen. Okay, before the conquer this scenario, we have to understand some BGP features with this scenario. One is Next-hop-self, the other one is BGP Spirit Horizon rules. Let's see what BGP Spirit Horizon rules first. This is BGP Spirit Route Reflector and BGP Route Horizon rules. As we know, in BGP, the local router will pick the best prefix and then advertise this best path to these neighbors. If the prefix has the root type internal, this is IBGP, then the local router will not advertise this path to other internal peers. Okay, BGP Speed Horizon rule says that if I receive root from R3, then when R1 want to advertise that the route to switch 2, because we have IBGP neighbor between them, R1 will not update AS path attribute. And if I go to switch 2, I will see next hop of that prefix as this root here, as R3 interface. Okay, I will show this in later in configuration. This is BGP speed rules. This is because within the AS, BGP does not update AS path information when sending update to internal peers. The fact that the AS path is not updated the fact that AS path is not updated eliminates BGP primary loop prevention mechanism to do not prefix move the AS path content to local AS. Okay. As a result, IBGP neighbors do not advertise received IBGP routes between each other. This requires IBGP peers to be in full mesh design. IBGP peers are peers of all other BGP peers. This is a scale problem. To avoid this, you have to use other configuration. You have to use either route reflector or configuration, BGP, or use BGP configuration. We can, for example, if we have 1000 IBGPs, we can use BGP reflector or configuration for making all of the IBGPs full mesh. Okay, then we have to configure switch 2 as route reflector and router 1 as route reflector client. Router 1 and router 2 with the client. We have to make R1 route reflector and make router 5 and router 6 route reflector client to make this IBGP full mesh. This is for this scenario. R1, 2, 1, 5, and 6 must be able to receive other routes for neighbors goes down. Another one is feature is Next-hop-self, that has said before. The other one is route reflector. In Route Reflector, we have some rules. Let's review these rules. Then I will go to jump into configuration. Okay, in Route Reflector, we have client, we have Route Reflector, we have client and cluster. These are non-client. This one and this one non-client and client. In Route Reflector, can have three types of pairings. One is IBGP neighbor. This is neighbor to our Route Reflector. The other one is IBGP client. This is neighbor between our Route Reflector and client inside cluster. This is the same inside cluster client. And we have non-client neighbor. This is between our Route Reflector and client outside cluster. This is non-client outside cluster. This is Route Reflector rules. Routes landed from IBGP neighbor can be forwarded to another IBGP neighbor, a client and non-client. If we have non-IBGP, here it can be to client and non-client, but we don't have IBGP neighbor here. Then route landed from a client inside cluster can be forwarded to another IBGP neighbor, client and non-client. Route from client can be forwarded to another IBGP, client, other clients inside cluster, and non-client outside cluster. If we receive route from client inside cluster. And if route landed from non-client outside cluster can be forwarded to another IBGP neighbor and client, but not non-client. This is normal IBGP route. Here, if you are receive route from non-client outside cluster, it can be forwarded to client IBGP, but not non-client outside cluster. This is normal IBGP rule. This is the same. Route advertising received from client. This is advertised to clients and non-client piece. And route received from non-cluster can be advertised to other client inside cluster and IBGP peers, and do not advertise to other non-client outside cluster. This is normal IGP rule. This is BGP Route Reflector rules. To make Route become Route Reflector, we have to conquer this command Route Reflector client and Route Reflector. We will see this in configuration later. Okay, now let's configure. Let's configure R1 first. In R1, I have to configure. Let's see. Show BGP summary. We have a BGP session. We have configured in the previous lesson. Okay, now R1 and 2 should become Route Reflector clients. Let's configure IBGP. Okay, showdown pipe section .abgp. Okay, config T. See I.abgp. So BGP from IBGP. Okay, I have to use loopback interfaces instead of physical interfaces as neighbor. If I switch to here and show IP interface brief or VLAN 122. This is interface. I have to use loop back of one neighborship. Okay, loop back. Okay, just from neighbor. Neighbor address. This is neighbor. Remove it because this is IBGP. It should be the same AS as local AS. 61. This one. Oops. Local AS. Then I have to use update source. Update source loopback 0. Then I have to go address family IPv4 unicast. Then activate the neighbor. Okay, this is the same con. We have the same R2. Let's see the configuration. This is R2 configuration. '65 1.2. We have neighbor 22 and activate. Update source. This is the same configuration for R2. Config T BGP and activate. Okay, now I have to configure Route Reflector switch 2. Config T. I have the same local AS and I have to use the loopback interfaces, loopback addresses 111, 111 and 222 and 222. And activate on the address family. So this is 65012, 65012, 65012. Okay, I think I have misconfigured R1. R2 is R2. Okay, this is not. I have misconfigured this section. Exit. this is should be 64.1.2. Okay. Then this formally activate. Because this is IBGP, the local AS and remote AS should be the same. This is for IBGP. Like here. Local AS and remote AS should be the same. Okay. Now this is Route Reflector. 65012. This is neighbor R1. Look back of R1, look back of 2, and activate this one. This is Route Reflector. Switch 2. And I have to configure this command for becoming the reflector. I have to configure neighbor. Under address family, I have to configure. I have to tell that you tell R1 and R2 that you are with the client. Neighbor 1 with you are with reflector client. Same as here. 222. I am telling R1 and R2 that you are with reflector client. Okay, now if I do show IP BGP, show IP BGP summary, I have neighborship. This is okay. This is Route Reflector. I have configured switch to as Route Reflector. Switch to Route Reflector and R1, R2 as Route Reflector client. I have to configure the same here on 5, 6, and 7. Okay, let's 5. On 5 I have 64056. This is 65. I'll compare here. This is Route Reflector client configuration. Route Reflector client configuration, and this is Route Reflector configuration. Route Reflector client, I want this is Route Reflector neighbor loopback. This is both. This is configured for 5 and 6. On 5, this local AS and remote AS the same local. This is Route Reflector loopback address and activate. And I am using update source as loopback. This is configuration for 5, 50, 5 and 6. 50, 5 and 6. And 7 is our Route Reflector. I am using this and telling that I am using loopbacks of 5 and 6 as loop update source. And activate this. Config T and activate. I have to use this command either. On the address family, I have to use these two commands. Loopback, Route Reflector client, and neighbor 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555  555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 555 5, 6. With the reflector client. And do show IP BGP summary. We have IBGP sessions between these devices. Okay, now let's see. We have configured route reflector, 7 are configured as 7 as route reflector, and 5 and 6 as route reflector clients. I need to configure Next-hop-self now. Before I configure the Next-hop-self, this is our IBGP speedwire rules that IBGP when I want. Oh, let's show what I want to say. If I go on switch 2 and to show IP BGP, now this is loopback R3 loopbacks. Switch 2 is seeing this part, this network. Next hop is 101. If switch to when I want to reach this network, it will use this next hop. This is next, and this next hop is attached to this R3. If I go to R3, this is R3 address. This interface address. This is not best path. We don't have best path for this. I can either advertise this link on the ERGIP, or I can use Next-hop-self. I have to use Next-hop-self on R1 toward switch 2 to tell switch 2 that I am that use my IP address as Next-hop. R1 will tell switch 2 that use my IP address as Next-hop. But now switch 2 is using R3's address as Next-hop. Okay, let's go to R1, and I have to go on the address family. This is address family, and use neighbor 2222 Next-hop-self. R2 either neighbor 222 Next-hop-self. Now if I go switch 2 and show IPBGP to show IPBGP. Okay, now we have valid best, and now I have best path. This is now valid. This is using R1 and R2 as Next-hop-self. I have to configure 5 and 6 either for R7. Okay, now let's go to this is address family, and I will go say neighbor 555 Next-hop-self, and I see neighbor 777 Next-hop-self. Now I go show IP BGP. Now I have valid Next-hops path. Okay, now let's check up the source. Let's check this with the stand section. Now I go on our one to show IP interface brief. I will shut down this interface. This is between switch 2 and our one. Exit interface, this one, and do shut. Now I do show IP BGP summary. I have IBGP session up. Let's ping. The physical interface is down, but my IBGP session is up. This is because of I have used update source command and loop back. Additional shot. Now let's check. Make sure this one is working. 1 2 5 and 6 must be able to receive routes from other AS if the corresponding IBGP neighbor goes down. Okay, now I will shut this link between R1, IBGP link between R1 and R3. Let's do this on R1. Do shutdown pipe section with a BGP. Let's go with a BGP. With a BGP, and we have name. This is IBGP neighbor, and shut down. To show IBGP summary. Okay, now I don't have any IBGP neighbor this time, but if I do show IP BGP, I can receive prefixes from this Next-hop, from R2. This is going this path. This is going this path for these prefixes. If I look 9, this is 9, this is using 5, 6, 9, this is AS, this AS. Then it is coming AS3, it is coming this AS. You see R9 is coming this AS and coming this AS. Then it is go 5656, this is going this path. Because this link is down. Then it is going 4, this is coming here and coming here. This is going this path because this link is down. This is the path for R9. Now let's back our IBGP session. needs to know. Move on up. Let's try. If I see the same null, it is going to 3 and 0. Now it is coming this path. It's coming 3 and 1. This is up. Okay, this one is working. I hope you have enjoyed this video. Thank you for viewing.